I had technical issues and disconnected from the previous streaming, but I would make sure to put everything together as planned. So I got to see that what I was sharing all along was not showing, so I would backtrack a little to the beginning of this page where we were implementing this. So this is what I was showing to you. I don't know if you can see my screen. I think it's still not. Okay, I think this is much better. So yes, I was talking about deploying this and all the steps that we're going through to deploy everything here. The first thing is to set up our VPC, and I came to the VPC page, searching through the VPC here in the search bar, and then you come to the home page. You can create VPC here and you start with a default setting. If you put VPC and more, you have all the extra things that we need to set up already kind of in progress here. Whereas if you have just VPC only, it's only that outer shell, not the subnets, not the route tables that define how the subnets should route like or the network, or not the internet gateway or the VPC endpoint for S3 that comes by default. Everything you can get it in VPC and more. So this is the preview of everything that is going to be set up by default with this kind of setup. This is the preview. You have the subnets, 4 of them. You can see there are 2 different availability zones here. The region is EU Central 1, and A says availability zone A and availability zone B, basically EU Central 1B availability zone. And for each of them, you have the public. You can check the names. You will see everything in the setup here, basically. But when you look at this, you see that a lot of things are already created for us from our architecture diagram. So this is the internet gateway. IGW is the internet gateway that grants like external internet access into the environment, into the VPC environment. And this VPC endpoints S3, like I mentioned, is the connection from our VPC, from our isolated virtual private cloud, to the S3 service without traversing the internet. So this is going to be securely within AWS connections, not going through the internet to transfer files or to get files. No, it's not doing that. So yes, this is the default setup that we have here, and we're going to be scrolling down. From our guide here, it's been told to us that when we are creating, we should create VPC and more, and we will see our review, then we go ahead and explore all the connections that we're going to be creating. The next thing for us to do would be to create our NAT gateways. There are things that would not be automatically, or that they are not by default in the VPC package that you get with the VPC and more. Things like NAT gateways, your security groups, configurations, and all that. You need to set that up by yourself. Yes. So here we have NAT gateways. Create 1 in each availability zone. You see it here in bold, 1 per AZ. So we're going here to our NAT gateway. Our NAT gateway is down here, and we're going to click 1 per AZ. So going through everything, you can explore all the different settings that are here, but basically by the default one is okay for this particular deployment. You can change it up. Here you can say maybe you want up to 3 availability zones instead of 2. We have 2 availability zones in our architecture diagram. And if you only want 1 availability zone, which is just one deployment setup, that also works fine. And then the number of public subnets is 2. The number of private subnets is 2. 1 subnet in each availability zone, 1 public subnet in each availability zone, and 1 private subnet in each availability zone. Don't be deceived that, if you have 1 private subnet here, you have 1 public subnet there, you use it together. It doesn't work like that. So you just want to have a copy, a replica of that particular setup that you have here in the other availability zone. We're making it highly available, basically. If this one goes down, the other one is still running. And here we have NAT gateway. We've selected 1 per AZ. We want 1 in each availability zone. And our VPC endpoints is S3 gateway. We want it. You can say none if you don't plan to have a VPC endpoint for S3. You can say none, but our architecture requires it, and we're going to work with that. And after we are done with that, we can create our VPC and we can move on to the next resource. So we'll come back and answer these questions, but let's create our VPC first. You can see all the different resources that it's creating. This is why you should be very careful with AWS, because it looks like, I just opened VPC and I clicked 1 button at the end and it's deploying like 20 resources in my environment, some of which would cost money, but we'll come back to this. So here we're looking at these questions. What is an availability zone and why do you use more than 1? An availability zone is a collection of resources in AWS location, a physical location. It's a 1 or more data centers. I used to say collection because if you say 1 data center, it's like 1 building, but it might be like a whole campus, basically. So it's a group of 1 or more data centers in an AWS region. And when you use more than 1 availability zone, like we've said multiple times, it creates redundancy such that you don't have 1 single point of failure for your deployment. And that equates high availability. Benefit of creating 2 NAT gateways is still about redundancy, because if one doesn't work, the other one is going to work. Imagine we have only 1 NAT gateway in 1 availability zone and that availability zone goes down. Even if you have all your deployments in the other availability zone, it wouldn't work because you don't have any NAT gateway that it's meant to use, basically. So when you are talking about high availability, your core resources that are important, you want to make sure they are redundant. Your core resources, I say core resources because if you check well, it's not every single thing that you may be duplicating. But yes, everything that is working with your application should be duplicated. And the maximum number of subnets in Amazon VPC is 200. 200 per VPC. When migrating to AWS, what do you consider? I mentioned this while we were looking at the architecture. It's important to pay attention to every little detail in your architecture. The CIDR blocks were already written there somewhere. For each of those subnets, for each of the VPC, you see the IP address ranges that was written there, 10.0 point something /24/36. They were written there so that when you are creating it, they are assigned correctly, because you don't want overlapping addresses in your environment. Even if you have more than 1 VPC you want to connect, you don't want them overlapping. You're connecting your local environment, like your physical on-premise, to AWS, you don't want them overlapping. Those are all the things, you just don't want them overlapping. And yes, next. Now we're going to be looking at security groups. Remember, I said that when you are working with the VPC, it's, even though there's a whole VPC package that you have coming by default, you won't have every single thing set up for you from the beginning. You may need to change your arrangements in your VPC, and definitely you need to configure your security groups by yourself. So security groups are essential for security in the AWS environment. All the resources that you are doing, all the resources that you are deploying should be deployed in a security group. And the security group, you would now have your rules configured for that security group. Rules on what can get into that security group, what kind of requests, what kind of connections can go into that security group, and that restricts. It's another layer of security that prevents external attacks or stuff like that from getting in, because you've already predefined who and what can get access to the security group and on what terms. I'm talking on what terms, you're talking which kind of protocol, on what ports, on all those kind of things are configured in your security group. And I also like to remember, or I remember and I like to remind people that security groups are also like one of the easiest ways to quickly respond in an attack to. Like, you have this security group that is already predefined and is closed off from any external influence, and then you see like weird behavior and you quickly change the security group of your server, so it is suddenly closed off from external connections because you have moved it to another security group that no external connection will be able to get into it from. Like, there are different, I won't say different reasons, because security group is used for one thing, but it's important for a variety of reasons. Yes. So now we are going to be working with our security groups. Security group is part of EC2 instances, EC2 services, and the EC2. Here you can see it's on EC2. This EC2 is the equation of instances, servers in AWS environment. It's the equivalent of servers in the AWS environment, I would say. It's not equation, because you might see a lot of names and you wonder, okay, what is this and why is it named that? Well, yeah, you have it. Elastic Compute. I'm coming. Let me open EC2 here for you. Okay, our VPC is successfully created. We can view it and then continue. So this is what it looks like. We didn't change the name. This was what it automatically generated for us. Project VPC. And this is our VPC ID. It's here. You don't need to cram it. It's always here. You can use it for other kinds of setup, but it's always there. We're going for our EC2. Yes. So virtual servers in the cloud. Virtual servers in the cloud. That's what the EC2 instances are. We have 0 instances running right now. 0 instances running. So this EC2 that we always talk about is actually, if you ask me, I'll say it's EC squared. It's meant to be like C to the power of 2, because if I remember correctly, is Elastic Compute Cloud or something like that. There are 2 C's there, and then they said EC2 about. That aside, let's continue. So we're deploying our servers, and here we are going to firstly create the security groups that we want to associate all these things with. Remember our architecture here, bringing it up for reference again. So far what we have created our availability zones in this region with our subnets. Like, we did all of that with our VPC setup. This purple VPC you can see here. So we already defined everything that we want to create. These 4 subnets inside these 2 availability zones in this region. So we've already deployed like more than half of our setup with the NAT gateways. And now what we want to set up is our application load balancer, our web server, and connect everything well together to work together. So our web server and our application load balancer are in a security group. And they are in security groups, and we need to define that also. It's an EC2 instance. In your sidebar, you would be able to find the security group here under network and security. So we're going to security groups. Oh yes, we have default security groups. Default security groups. Let's look at it here. You can see they are in 2 VPCs. You see security group in the default VPC security group, and then there's another default security group in default VPC. You'll be wondering why we have two default security groups, and when I showed you here, I told you there are two VPCs here. Two VPCs. We created only one, right? There is a default VPC that comes with your AWS account when you open it. If I open VPC now, you see there are meant to be two, I believe. There's one that is default, and then we created this one that we wanted with the configurations that we wanted. Here we can have a look at it quickly before we continue. VPC, fingers crossed, there should be two. Yeah, there are two. There are two. You can see two VPCs. You see this one that has no name is the default one that was created, and this is the one that we have with our project VPC. For you to be safe, normally try to create a different VPC whenever you are doing whatever in your environment, because there's a lot of restrictions with this default VPC. For instance, you cannot use it with VPC peering and all of that because of the CIDR range, this IP address ranges. It gives you a lot of restrictions on what you can use it with. But basically, we have two VPCs, and this is the one we are using, our project VPC. Take note of that so you don't mistakenly use the wrong resources when you're connecting things. Yes. So now, going back to our building website, we are in security groups, and we're going to be setting this up. So here, security groups, we have default security groups that are there, but we're going to create our own security group. Let's go back to security groups in our EC2. Security groups in the EC2 feature. I'm going to create security group here. There are no rules yet in our security group. Everything is default. Let's see what we're meant to set up for our environment. We have to set the settings as they want it to be. So the name of our security group is going to be Load Balancer Security Group. I believe this is the one for our load balancer. Remember, we have two security groups we're going to be setting up. The description is external access. This makes it very easy for us to work with. And we are going with the VPC that is our project VPC. So we have to make sure we select this one that is the project VPC. And the inbound rules, let's check what inbound rules we have here. So in the inbound rules, we're going to add a new rule, and this is the entry. Remember I said that you're the one that's going to define exactly what can gain access to the resources in your security group. So instead of having to set this rule or this restriction per resource for every resource, you can just attach it to a security group, and then these resources that you want to have the same kind of restriction and all that, you put them in the same security group, and then you can just handle the security group directly. Here, this is what we're going to be working with. HTTP on port 80. HTTP is always port 80, and then the source is from anywhere. This is totally open. It's not very safe, you get. But for the source, you could restrict it to particular IP addresses. You can restrict it to another security group in AWS instance, in AWS environment, and all that. So it's really flexible for you to define, and we're going to work with that. The type we have here, it should be HTTP. We have it here, and then you see we're not able to exit it. This is what I said, like HTTP is always port 80. These things are by default the protocol and the port range. And the destination, no, well, okay, no, this is not. I made a mistake here. I was tampering with the outbound rules, but I'm just going to leave it as it was, because here we had anywhere, or rather it was, I think, the security group. Let me just open it again. Yeah. I'll paste this all over. But don't make the mistake I made. I was tampering with the outbound rule instead of the inbound rule. It doesn't really make a lot of difference, actually. I'll explain why. But outbound rules, you can see it allows all traffic to go out. It's totally unrestricted. But the inbound rules is the one that's important for security groups, because with security groups, all traffic is allowed out by default, but only what you allow in comes in. and it remembers its way out. So even if I remove this outbound rule, I delete it or whatever, by default in security groups, they are what we call stateful. Security groups are stateful. It remembers its request, and whatever goes out is allowed to come in. Okay, yeah, it's whatever goes out is allowed to come in. And then this inbound rule is what we are setting up right now with HTTP AT from anywhere, and where you have this description. So let's go. We add a rule for HTTP port 80 from anywhere IPv4, and then we set this, and that's all for this rule. Yeah, do we have another rule? I think not. We don't have any other rule. We have only one, and we can add tags to it. So tagging your AWS resources is not a requirement, but it just makes life easy for you when you're starting to track your costs and track whatever project you're working on, and separating them. Okay, this project is for this, this resource is for this project, this resource is for that project. That's what tags really are for. They're not useful for the actual resource itself. It's for your own self and your own processes. So our new tag, we are going to add the name, and it's basically free for you to put anything you want to put. It's your, and that would be all. We need to create another security group also after this. So we create this one, it's there, and we would create a new one. So this one is a load balancer security group, and this is our security group ID. We also have VPC ID. We have IDs for almost everything, and we're going to go back to security groups, and we'll create another one the same way we created this. So the name is going to be web server security group, and the description is going to be web server access. I'm putting that here, and the VPC is going to be our product VPC as expected. And these inbound rules from our architecture, if you remember what we were looking at, only the load balancer security group was able to communicate to our web server security group. Let's confirm if that's the rule that we have here. Yes. So you can see we have HTTP port 80 from the load balancer security group, and the description says to allow HTTP only from the load balancer. Comparing this with the other setup we had here, the source for our load balancer was from anywhere, like from 0.0.0, from anywhere, and here we have from load balancer security group. So that's what we're going to be working with. And I'll also show you something when we're working now. You will see that when I select this HTTP and the source custom, I'm able to come in. Oh no, this was not. This is what I'm putting in the description. But I want to copy the load balancer security group. Should be able to search it here and select it from, because we created it first. So the order we created this also matters. We wouldn't be able to select load balancer security group here if we're trying to create this one first. That can be an issue if you're trying to do things out of order in your environment. Sometimes that is the source of the errors people are running into. When you're even using code programmatically to create these things, not putting the right dependencies, like, okay, create this one first before you create the next one, can cause you a lot of issues. So here we have the load balancer security group, and that is all except our tag. We need to add the tag here. Name web server security group, and that's all for us. You see, we're done with our security groups. Yes, and create security group. That's all. So we have 2 security groups that we have created. There are other 2 that we didn't create, but I mean, with our VPCs here, you'll be able to see this one's in our VPC. So web server security group and load balancer security group, ready to go, and we can move on. Aha, this test your knowledge. It's interesting. So the default inbound and outbound rules when creating a new security group, we saw them now, and the inbound is empty. Basically, nothing is allowed into your security group by default. And outbound, everything is allowed out of your security group by default. That's what we have here. And why is it not recommended to use HTTP for production web server? So normally you want to use HTTPS, like you want to use secure um, connection for your environment. We use HTTP because we are not dealing with all these certificates and all that right now. But HTTP is not very ideal. Can a security group have multiple inbound and outbound rules? Yes, it can. What type of resources you can protect with your security groups? You can use to protect a lot of resources. Your EKS clusters, your servers, your load balancers, your databases, RDS, all of them basically that you deploy in subnet and all of that. You can specify what security group that you want them to be in. And next would be IAM management. So we have IAM management, we're familiar with it. We set up a user in the first lesson that we had, first episode, like 2 weeks ago actually. And today we're actually not going to be setting up a user, but I believe we'll be setting up a role. So when we looked at it the other day, I tried to show like some different entities we have here. Yes, this is a dev user that does not have access to all these IAM things. But here you can see user groups, users, roles, policies. Like there are different like resources that you can create, like policies, and attach it to a role, or attach the policy to a user, or there are pre-made policies that exist in the environments that you can attach to a role. So basically all of this is, I can create roles. And AWS, let me go back here. So this is how our web server is going to be communicating. When you are deploying a server, you want it to have its own instance profile. You don't want to be using the same way in your CLI, where we configured it, that you put in your AWS secret key, AWS access key, all of that. No, you want to actually attach a role to that server so that when it wants to perform instructions, or when it wants to do anything in the AWS environment, it would only work with that role. It will assume that role and work with it based on the permissions you have given that role automatically. So yes, that's what we're going to be doing now. We're going to be setting up the IAM role, and that will be here. We're going to select roles, we're going to create the role, and we're going to attach policies to that role. So let's get started with that. Here we're going to create a role, and this role is for an AWS service. Remember I said there are different kind of entities. So this is AWS service that we're attaching, that I'm creating this role for, and that is EC2. We are creating for EC2. Let me see the exact thing that we're following here. EC2 for the use case, and then we're saying EC2 role for AWS Systems Manager. There are different use cases that were listed that we saw just now. We don't need to dive into them, but basically what we are doing here is just giving it access so that it can call like very simple services that AWS Systems Manager needs to work with the instance on. So we're going to be picking EC2 role for AWS Systems Manager, and we're going next. Yes, I mentioned that this user does not have sufficient access, but I guess we can quickly get that sorted. If I will log in to the root user and then I am going to do that. Now I'm going to add console, sign into a new session with my root user email. So it was essentially the restrictions that I had placed on that particular user. It only has access to perform commands in the console, but not access to create users, to view views and all that. So we're going to follow the same thing, creating a role here. And I'm going to use AWS service for EC2, and I'm going to select EC2 role for AWS Systems Manager, the same way we did in the former one. So next, and the policies, I think this is all. I'm not sure we need one. Let's check here to confirm. It's only the SSM manage instance core policy that we need to add, and we are going to name the instance, the role, this web server instance profile, that's the name of the role. We're going to add it and we're going to create the role, and that will be all for us here. So next, I add the name of the role and I'm creating it. So yes, I've created this role here, and exactly what's the difference between an IAM role and an IAM permission? What difference is there is that the role is actually what uses the permissions, whereas the permission just defines what it can do. So permission itself cannot do things in the environment, but a role can do things, a user can do things. Should you always use AWS managed policies to secure resources? As much as you can, you should, but there are times that you would need to create custom least privileged policies that are directed to specific groups or specific kinds of users or roles. But if you are using for AWS services like this, or where the permission is really well defined, clearly what it needs to be done, you can use the AWS managed policies instead, so that you wouldn't be running into issues down the line because you forgot to add one line of permission or something. And what are the key benefits of using AWS System Manager to manage the web server instance? So we are connecting this role because we want to use AWS Systems Manager to manage the web server instance. There are different methods, but a lot of them would be exposing the server to external connection, which we want to avoid. So with AWS Systems Manager, we are able to log into the instance, the console. Through the console, we're able to log into the instance terminal and run commands on the instance as if we were running the terminal from our local machine, basically, without exposing it to the internet. Yes. And what security principle does the IAM setup we just completed aim to follow? It's the principle of least privilege. We only attach the permissions that was necessary to the EC2 instance. Imagine we gave that EC2 instance administrative access. That's not what we want to do. Yes. So we gave it only the permission that it needed. It was only working with SSM stuff, and that's what we gave it access to. And that's all for our IAM setup. So this EC2 deployment, I will deploy it here. It's not much actually. What we need to do is to go to the EC2 service. So everything we are doing is still within our architecture setup. I just want to make sure we deploy everything here before we go. We've set up most of it already. The regions, availability zones with the private cloud, our VPC, with our NAT gateways, our public subnets, and the internet gateways. Everything here is mostly set up NAT gateway. The point we are at now is our web server and our application load balancer. These two, we've not yet deployed them. Everything else is already deployed with our security group existing and all of that. So now we are going to be deploying our web server. And here we have coming. Yeah, so this is our root user. You can see it here, and I don't want us to continue using our root user. So I'm going to be switching to the dev user, which we have here. Remember I said I don't do things with the root user account. So this is the dev user that we're going to be using. We're going to EC2. Here we have deploy the compute. So we want to deploy our servers into the AWS environment. We've set up the environment we want to deploy it in. We just need to mention, okay, put it in this particular security group, in this particular VPC, everything else we've created, put it there. We've gone to EC2 instance. We're going to launch the instance and we're going to name it my web server. So here, 0 instance running. We're going to come here, launch instance, and we're going to name it my web server. As I said, scrolling down, you get to select what kind of operating system that it gets to have and the size of all this. Yeah, basically configuring what options you want. We're selecting Amazon Linux 2023, Amazon Machine Image, and 64-bit architecture, and that's what we have by default, so we just scroll past it. The next thing would be the instance type. We're meant to have t2.micro instance type. So there's a whole documentation on the EC2 instance family and the different EC2 instance types, their size, their speed, and all of that. You can look at it if you want to. Just Google EC2 instance family, you will get that, or EC2 instance type. I think documentation should also come out. And I said this because it's important for you to know what you are getting into. These instance types are not the same price. All of them are different in price. They are different in size. Not all of them are free tier eligible. Some of them are not. So just know what you are deploying anytime you want to deploy EC2 instance. Check it out. We selected the EC2 instance type, and this is the default setup for this instance type. We have normally SSH keys, but in this case we are using systems manager to connect, so normally you don't use SSH with systems manager. SSH is giving access from your external machine to connect to the EC2 instance, so you have to expose the port you want to connect on and all of that. But with AWS Systems Manager we don't need to do that. That's why we configured AWS Systems Manager role on the EC2 instance. We are proceeding without a key pair. And proceed without a key pair. The reason why it says not recommended is not because you need to use SSH. It's saying not recommended because once you launch the instance without creating a key pair from the beginning, you won't be able to create a key pair again. You would have to create a totally different instance to have a key pair. Like basically, once you create it, this is something you cannot change anymore. So if you are creating the instance, it's better to create the key pair even if you don't plan to use it with SSH and all that. But once you create the instance without the key pair, you won't be able to add the key pair. At least if I remember correctly. Yeah. So in network settings, click edit and we'll configure it to use the private subnet that we have set up. That's what we're going to be doing. It's going to be in, let's see, edit this network settings. We're putting it in our project VPC, remember? And we're using not the public. You see, it's selected public. We're putting it in the private subnet. In the private subnet. Make sure that's clear. And private subnet 1, that's what we picked. What else do we need to configure? Firewall, that's the security group. So we're going to select our security group that we have created, and then we can move on. So we select an existing security group. You can also create a security group from here, but I mean, we already created it. So we'll click the web server security group. Remember, that's the one that we're putting our web server in. This advanced network configuration, there's not much we need to do here. I believe everything is already. Yeah, the instance profile we created. So here we have our instance profile. Sorry. Here. Advanced details. Instance profile. So I can write the instance profile there. I'll copy it because I have access to this other one. I just need to open the EU Central, just where we are. And I'm going to the roles because I need the detail of this role. Normally you should be able to select it there, but because I restricted the access of this user, I'm not using the root user, I'm not able to see every single role there. So I'm going to copy this ARN, and that's what I'm going to put there. I have to write the full name. Well, maybe I just copy the name instead. But it should work. Yeah. So I put the name of the instance profile here, and I think that is all that we needed to update in the advanced details. And yes, the user data. So whenever you're deploying your EC2 instance, anything that you want it to do, like while initializing or like at the beginning, you can put it in your user data. So anything you put here is run on boot. Anything you put here is run on boot. So you want it to set up some things, install this, install that, get the web page, fetch something from GitHub, all of that. You can put it in a script here and put it there. So that's what I'm going to be copying and putting there. This essentially, it installs the session manager agent. That's the SSM agent. And it installs and starts a PHP web server. It goes through all this systemctl, starts HTTPD. If you know HTTPD, you know it's a web server too, like Apache. And install the SDK for PHP, that AWS SDK for the code thing. You install web pages and it updates it. It's basically setting up a web server in this setup. I'm going to put it in the user data. So let me close everything so that we can see clearly what we have here. So in advanced detail, user data, I think should be somewhere here. Yes, in user data. So you just come and paste it here. You can also upload a file from your system if you have what you want to upload, and that makes it very easy. I believe at this point now we should be able to launch our instance. Yes, once we launch it, it would spin the instance up and to let us know when it is completed. Aha, I am not able to assign a role to a user. I created this user with power user access. I think at this point it's best for me to just I'll give our user an additional permission. Mm-hmm. Currently it has power user access, yeah. But for now I'll put let me add permission. Attach policies directly. Let's see what we have here. I want to give IAM full access. So I want that user to be able to manage the roles and all that. So I'm giving IAM full access to add permissions, and this user should have that. Yep. So I'm going back here to our launch instance and I'm going to retry failed tasks. It worked. So all the restrictions around IAM is solved once and for all. We shouldn't be encountering that again down the line. And that's the way to solve it if you want to. But essentially you don't want to just grant IAM full access to anyone. But because this user is going to be trying and learning a lot of different things, including IAM, so I think it's best to grant that access. And here we have launched, everything passed, and we can go. Our checks too. Yes, 2 of our checks. Let me see instances. I should have running. Let me check it here. Status and alarms. Let's check it here. It's still checking the status checks, the instance status checks and the system status checks. But when we come back here, we should see everything passed because we didn't do anything special in our environment. So how many different EC2 instance types are available? Over 800. That's why I said check the documentation before you deploy stuff. There's a lot. The instance families, they group the instance types, and within a family you can see different types. The ones that are optimized for compute, optimized for memory, so many different ones. And not everything is eligible for free tier. I'm saying it again, not everything is eligible for free tier. What is a key pair and why do we need it? So we use it to establish SSH connection. Private key, public key, it's a pair. The public key is on the instance and the private key, you download it and save it on your own system. So whenever you're trying to establish SSH connection, you would reference that key file and tell it to make the connection with the key file. That's how it works. And we are not using it in this environment because we are able to connect to the instance in the AWS environment because we set up AWS Systems Manager for it. What is the purpose of the user data feature? We talked about it for you to configure your EC2 instances to run commands on boot. So as it is running, it is going to be as it's starting, it's going to be running all those commands with the booting. You don't have to wait for it to finish and then you now go back and start running it by yourself manually. You don't need to do that. Compile it, put it in the user data, and launch the instance. And then we have it. We have fully deployed our EC2 instance. Now we are well over our time. I would like to apologize because I took extra 18 minutes because for a period during the session, actually, my screen wasn't showing as expected. I got feedback in the chat and I had to take some time to go back to recover the parts that had already passed. So we'll be continuing next week. We will learn how to go into our web server and check things there, to run things in our web server, to basically work with it. And we'll deploy our load balancer, we'll test the web server, configure the storage connection, and then the auto scaling group. Remember I said originally in our architecture I see only one instance here, and we're using an application load balancer. At the end, we would be configuring our auto scaling group ourselves. It's not there in the architecture, but we'll learn how to do it together. So we've successfully reached 50%. If you ask me, I'll say more than 50%, because from here we already have almost all of the architecture deployed except the load balancer, and we've not yet connected to S3, but everything else is deployed. So yeah, good job. Thanks for staying with us today. Look at it, our EC2 instance here. We should have it running fine before we go. We have to see that status check green before we go. Yes, 2/2 checks passed. Thank you for staying with me today. I wish you a nice day, or rather a nice night if you're in the night like me. Bye bye.